Going on to section 4 of chapter 7, where we did multiplication. Now we're going to do division of radical expressions. And we're going to be doing dividing and simplifying. And we're also going to do something that's called rationalizing denominators or numerators with the one term. Now remember, we can multiply anything by 1 and not change its value. In fact, that is one of our key words right down here. Multiply. Multiply by 1. Now, we use this back in Math 100 a lot, where we had the fraction 2/3, and we want to add it, let's say, to 1/6. Well, we couldn't because the denominators were different, but we were told we could multiply any number by 1 and not change its value. Now, in order to make this denominator a 6, the 1 we are choosing to multiply this by is going to be 2 over 2. Now, 2 over 2 is 1, but this then makes this an equivalent fraction of 4/6. Now they have the same denominator. So we're going to use this technique in section 4. We're going to multiply this fraction by 1, but the 1 is going to be in the form of the square root of 2 over the square root of 2. So when we look at the square root of 2 times the square root of 2, that's going to be the square root of 4, which is 2. And we get for the top 5 times the square root of 2. So where prior this denominator was an irrational number, we have made it a rational number through the process of rationalizing. Wow, what a perfect choice of words there. We are rationalizing, going from an irrational to a rational. And we're doing so by multiplying this fraction by 1 in the form of the square root of 2 over the square root of 2. So part of the strategy we will be working on is to what form of 1 are we going to use? That's where we're going. So some of these are going to be pretty simple and straightforward. So we have here a fraction. The square root of 81 is 9. The square root of 49 is 7. And we're looking for the principal square root. And here the cube root of this is 5. And the cube root of this is 4. And the square root of 16 is... Alright, here we have to use a little bit of our technique here. Let's move it up and look at this technique. So here, p to the 5th is not a perfect square. So I'm going to use that technique of the previous section. This is now a perfect square. This is what's left over. But our denominator is a perfect square, and we are allowed to separate it like that. So this becomes 4p squared, the square root of p, all over q to the 5th. Again, 2 there, dividing the 10 by 2. And in this next one, following the same protocol, we're going to divide this numerator into two parts, perfect cubes. So that will be 10 x to the second, the third root of x, and this is a perfect cube, and that's our answer. Again, the tedious part, putting it into MATLAB, but there again, you're sure to put everything in the right place, and we want accuracy. Working on strategy again, we've set some stuff up. We're now going to put a to the 8th, b to the 4th, and what's left over is b to the 3rd. And then here we're going to go c to the 12th, c to the 2nd. Again, we're dividing those into perfect fourths and whatever's left. Now we're doing sixth. So this will be m to the 6th, and then an m over here. And this is n to the 6th. And this will be p to the 18th, and then p to the 2nd. And let's finish these up. So this is going to be a squared b, the 4th root of b cubed. This will be c to the 3rd, the 4th root of c squared. And this will be mn, the 6th root of m, and this will be p to the 3rd, the 6th root of p to the 2nd. Now we're changing gears a little bit here. Here we have two radicals, same index number. We're going to put them under a common radical sign. And now we can do some canceling. This will cancel, and this gives me a 6. These cancel. So our answer here is just the square root of 6. So you are allowed to do this and simplify under the radical sign and then give your answer. Alright, to keep it a little shorter, I've kind of done some of the work here. So I put this under one radical sign. This is just going to cancel, and I get the 3rd root of 10. Now here, putting it under one radical sign, this cancels. I cancel one of the a's, so this becomes a 4. So I'm left now in the numerator with 3, a to the 4th b, that I can then put under 2. And again, some of this you can do mentally. A to the 4th, 3b. So this becomes a squared, the square root of 3b. Number 12 is rather tedious, but I did it so you could follow it step by step. I would do some of this mentally, but I wrote it all out. So here, remember there's a 1 out in front, so there's the 1/3. I then incorporated this square root of 3 under the radical sign. This will cancel, and I get here 27, which is what I have here. Now, there is a perfect square factor in 27, which is 9. Then I'm left with 3 xyz. So, can you see that this comes out as a 3? The square root of 9 is 3. These 3's then cancel. So there's our final answer for number 12. Again, it is a little bit tedious. I would have done some of this mentally, but I wanted you to see how it was done. Now I'm going to do a little bit of this mentally, or without writing it all out. 5 goes into 80 16 times. I bring my p to the negative 2 up. This becomes p to the 5th. And then I have q to the 2nd, bring it up, it becomes a negative 2, so this gives me q to the 3rd. I'm now going to use the technique of putting them into perfect fourths, 16 and p to the 4th with a p left over, q to the 3rd. This then becomes 2p, the 4th root of p q to the 3rd. Now, number 14, I don't know if you recognize this, but this is the sum of perfect cubes that in Chapter 5 we factored into these. A parenthesis for 2, parenthesis for 3, this sign, cube root of that, and then the pattern. And then in our bottom we had this. So these cancel out. So our final answer will be the 3rd root of this. And that's where it came from. Now in this section we're asked to rationalize the denominator. So we're going to multiply this by 1 so we get rid of the radical in the denominator. So which form of 1 are we going to use here? Well, it's the one we had before. Square root of 2 over the square root of 2. By the way, it's the denominator that causes us to choose it. And here we're going to use, this one's a little tricky already. It's going to be the cube root of what? Have to be the same. Now, it's not going to be 3t because that wouldn't make this a perfect cube. But if we went 9t squared, think about it for a moment, then that would work. And here this is also something to the 3rd power. And that's going to be an x squared y. So these are all 1s that when I finish will rationalize the denominator, and let's see what we get. For our top here, we're going to get 3 the square root of 14. Now square root of 2 times the square root of 2 is square root of 4, which is 2. 2 times 5 is 10. Now for this one, this will be 27, which is 3, t to the 3rd, which is t. And now our top becomes 2 times 9 is 18, s t to the 2nd. And here our bottom becomes x, y, that's what we're looking for. And our top becomes the cube root of 10 x squared y. So in number 18, they're giving us a challenge. So we have some preliminary work to do. Notice that 8 is square root of 4 times the square root of 2. So if we take out the square root of 4, we get 2, the square root of 2. And 50 is 25 times 2. And x squared is already a perfect square. So if we do this simplification, this is what we are at. Now, to rationalize that denominator, what 1 will we put there? Well, it's going to be the square root of 2y, and our top, the square root of 2y. That's our 1. But notice what happens now. We get this next step in which 2 times 2 is the square root of 4. Okay? And we're going to get then on the top 8, the square root of y. And on the bottom we're going to get 10, the square root of xy. But we're not finished yet, because here we can cancel out a 2 and get a 4, and this will be our 5. So our final answer for 18, wow, is 4, the square root of y, over 5, the square root of xy. And how about without the radical sign there? Yes, because here we did the rationalizing the denominator to get rid of our radical sign. So there's no radical sign there. So this is the answer. I apologize for that. Got carried away. Okay, so in number 19, they're going to change that instead of rationalizing the denominator, we're going to rationalize the numerator. But don't make it hard. Notice we can do some canceling here. 5 will go into there 3 times. 5 will go into there 7 times. So now our 1, and we're looking at the numerator. To rationalize that, we're going to multiply it by itself. So the square root of 3 over the square root of 3 is our 1. So then this becomes a 3, and this becomes the square root of 21. And again, we're looking at our numerator. This is going to become the square root of 121, which is 11. 5 times 11 is 55. And this is going to be 4, the square root of 33. We have rationalized our numerator. And notice this is to the third root. So our 1 is in the form of square root of the cube root of 25. So this becomes then 25. How about 5 here? Thought I was on a roll there for a moment. So this is going to be 125. The cube root of 125 is 5. And then this is going to be the cube root of 7 times 25, which I believe is 175. Okay. And the last one, it wants us to note again the index number of 3. So to get 3 to be a 6 to be a perfect cube, we have to multiply it by 36. 6 times 6. And then to make x to the 7th a perfect cube, multiplied by x to the 2nd, that'll give you x to the 9th, which then gives you a 6. X to the 9th divided by 3 is x to the 3rd. And then 5 times 36 is 180. And xy. Okay, so you'll have chances to practice. Again, you need to be really careful. Little errors can slip in there. I think we did pretty good on this one. And on to our next lesson. And under 20 minutes.